Hi everyone. So we're on to the next topic, which has to do with factoring. And we're going to start with the greatest common factor. Greatest common factor, or GCF. Before we get to that, we might want to talk, what do we mean when we say the word factor? Right? What is a factor? So factors are things you multiply. Right? So if I write 3 times 7, the 3 and the 7 are factors. Right? If I write x times y, then x and y are factors. Right? And if I write something more complicated, like w squared plus 3 times w minus 5, then the w squared plus 3 is a factor, and w minus 5 is also a factor. Right? We'll get to this later, but for now, just factors are things you multiply. Right? The results, right? When I multiply 3 times 7, I get 21. Right? The result is called the product. Okay, so just some terminology. I'm going to use these words, factors and products, over and over again, so make sure you know the difference. All right. Next thing is prime factorization. Right, so prime, you hopefully know what prime numbers are. Right, so prime numbers, right, have only two factors. Right, just one and itself. If I can spell itself. There we go. Right, so prime numbers, right, 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. Right? They go on forever. The ones we're going to deal with mostly are the single-digit ones, and maybe 11, 13, 17 occasionally, maybe 19. Right? All other numbers are called composite. So composite numbers, right, are numbers that have more factors other than one in itself. So 6 is composite because it's 2 times 3, 2 and 3 being prime numbers. Right? So any number can be written in terms of the prime factorization. Right? So let's start with, as an example, suppose we want to find the prime factorization of the number 84. So 84, right? Okay, so there's a couple of ways of doing this. One way you might remember are things called factor trees. So here's the tree, right? The top of the tree is the 84. And then you just find any two numbers that multiply to get 84, right? Other than 1 and 84. Obviously, you can always do that, right? But that's boring. So instead of starting with 1, I would start with 2. Right? If we divide 84 by 2, we get 42. Okay. And if we divide 42 by 2, we get 21. Now, can we divide 21 by 2? No, 21 is an odd number, so it's not divisible by 2, but it is divisible by the next prime number, 3. Right? So I started with 2, then I went on with 3. So 21 divided by 3 is 7. Right? And 7 is a prime number. So the only thing you can do with 7 is just 1 and 7. Right? So that's it. Right? Essentially, the leaves of the tree, right, are the prime factorization. Right? So we can write 84 as 2 times 2 times 3 times 7. And remember what we use exponents for when we see repeated factors, right? 2 times 2 is really just 2 squared. Right? So I would prefer to write it with exponents this way. Okay, so I'll let you try one and then we'll move on. So suppose you want to find the prime factorization of, let's do a slightly bigger number. How about 126? Okay, got it. So again, find the prime factorization, just do the factor tree. Find any two numbers that multiply to 126, right? So 126 divided by 2 is 63. 63 is not divisible by 2, so I would go on to the next number, 3, the next prime number, I should say, 3. 63 divided by 3 is, again, 21, right? And 21 is 3 times 7. So here the factors are 2, 3, 3, and 7. So you could write 126 as 2 times 3 times 3 times 7, or better yet, 2 times 3 squared times 7. Okay, right, so that's just finding the prime factorization, right? Right, now we can go back to finding the greatest common factor. Okay, so let's do that next. Okay, so to find the greatest common factor, you're going to do two things, right? It's just two steps. You find the prime factorization of all the numbers that are, right, that are given to you on the list. And then we're going to multiply each prime number raised to the smallest exponent that you see on the list. Okay. So here's our first example. Right. So find the GCF, the greatest common factor, of the numbers 36, 54, and 90. Okay. Now, again, maybe some of you think it's obvious. Great, but let's do this step by step, right? So these are the three numbers. We want to find the greatest common factor. Okay, so let's start with 36. So 36, well, it's 6 times 6, right? But 6 is not prime. 6 is 2 times 3. And this 6 is also 2 times 3. So we have 2 times 3 times 2 times 3, or better yet, 2 squared times 3 squared. Okay, so that's the prime factorization of 36. Now we do the same thing again with the number 54. Right? Find two numbers that multiply to 54. So I can think of 6 times 9 is 54, right? And 6 is 2 times 3, and 9 is 3 times 3. So we have 2 times 3 times 3 times 3, or 2 times 3 to the third power. Okay, so that's the prime factorization of 54. And now we go on to 90. So what comes to mind? 9 times 10 is 90. 9 is 3 times 3. And 10 is 5 times 2. Right? And I think these are, again, prime numbers. So 3 times 3 times 5 times 2. And I'll just put them in order. So 2 times 3 times 3 is 3 squared times 5. Okay. So we found the prime factorization of all three numbers, right? So we did step 1. Step 1 is done, right? Now on to step 2. So on each of these lists, right, we have a list of essentially these numbers here. So let me write them this way. So 36 is 2 squared times 3 squared, right? 54 is 2 to the 1 times 3 to the 3. And 90 is 2 to the 1 times 3 to the 2 times 5 to the 1. Okay, so now we can find the GCF. How do we do that? Step 2. Right? Step 2 says we multiply each prime number that we see using the smallest exponent. So we have a 2, right? We have a 2, and what's the smallest exponent? We have a choice between a 2, a 1, and a 1. So 1 and 2. What's smaller, 1 or 2? Of course, 1 is smaller than 2, right? So we pick the 1 for the exponent, right? Then we multiply by 3, because we have a 3 here, right? For all these. So now we have a choice between an exponent of 2, 3, or 2, right? So 2 or 3. What's smaller? 2 is smaller than 3, so we'll pick the 2, right? And then we have a 5, except here's the problem, right? 5 is not common to all three numbers here, right? So if you're thinking, but isn't 1 the smallest exponent? Not really, right? 54 is 2 to the 1, 3 to the 3, times 5 to the 0. And the same thing for 36, right? Remember, anything to the 0 is 1. So all I did was multiply by 1 here. Okay, so looking at it that way, what's smaller, 1 or 0? 0 is smaller than 1, so I have to multiply by 5 to the 0. But remember, that's just 1. This is 2 times 9 times 1, right? This is not 5 to the 1, it's 5 to the 0. There we go. 2 times 9 times 1 is 18. So 18 is the greatest common factor. Right? So that's how this works. Okay, so you find the prime factorization, right? Do the factor trees. Again, these are not the only ways to do the factor trees. I just picked the way that I like. And then you end up with the prime factorization, right? The list of numbers, and from each list you have various exponents. You just pick the smallest exponent, right? So yes, we call it the greatest common factor, right? But you're picking the smallest exponents, right? In other words, all three of these numbers are divisible by 18, right? So we could have written 36, right, as just 2 times 18. We could have written 54, right, I think as 3 times 18. And we could have written 90 as 5 times 18. So they all have 18 as a common factor, right? But that's the biggest factor that they have in common, right? I mean, they have smaller numbers that are in common, right? Like 6. 36 is 6 times 6, right? And 54 is 9 times 6. And 90 would be 15 times 6. So they all have 6 in common. However, that's not the biggest common factor. In particular, the 6, the 9, and the 15 are not all distinct prime numbers, right? They also have something in common, namely the 3. So it's 3 times 6, which gives you the 18. 18 is the biggest number that's common to all three numbers. Okay, but as long as you do these two steps, that'll always find the greatest common factor. Okay, so try this one. Okay, so find the greatest common factor out of the three numbers 42, 70, and 126. Okay, so step 1, 42. So this time I'm going to start smallest here. 42 is 2 times 21, and 21 is 3 times 7. So 42 is just 2 times 3 times 7. 70 is 7 times 10. 7 is prime, but 10 is 2 times 5. So 70 is just 2 times 5 times 7. and now 126. Hang on, to make this easier, let me put these in the same column here. 2 times 5 times 7. Right, and 42 is 2 times 3 times 7. Okay, so on to 126. So if you divide 126 by 2, again 63, I think we did this one already, didn't we? Right? 63 is 3 times 21, and 21 is 3 times 7. So there it is again, 2 times 3 times 3 times 7. So 126 is 2 times 3 squared times 7. Okay. So step 2. Step 1, step 2. So now we can write down the GCF. Right. So notice that all three numbers have a 2 in common. Right? The smallest exponent is just 1, so 2 to the 1. Right? You don't have to write the 1, right? It's understood. But the 3 is not a common factor, right? 70 is not divisible by 3, right? So we're not going to include the 3. Make sense? It's not common to all three numbers, right? Remember, there's an invisible 3 to the 0 here, so we could write 3 to the 0, but 3 to the 0 is just 1, and there's no point in multiplying by 1, right? Okay. Same thing with the 5, right? Only 70 is divisible by 5, right? The others are 5 to the 0, so we're not going to include the 5. It's not a common factor, right? However, 7 is common to all three factors here. And it's just one 7, right? 7 to the 1. So we do include 7 as a common factor. And that's it, right? So 2 times 7 is 14. The GCF here is 14. Okay, so I hope that helps. Right. So one more. Okay, so now here's 4 numbers, right? Find the GCF of 36x to the 8, 48x to the 5, 60x to the 7, and 108x to the 3. Okay, so don't worry about the x's just yet. We'll get to that later. Let's worry about the coefficients, right? The numbers themselves, right? So 36 is one we've done already, right? You can do 6 times 6, but let's do it this way. How about 2 times 18? 18 is 2 times 9, and 9 is 3 times 3, right? But we get the same result. 2 to the 2 times 3 to the 3. Okay. And then the 48, right? So 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So we have how many 2's? 1, 2, 3, 4 2's, right? So 2 to the 4 times 3 to the 1. Right. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. So we're going to get 2 to the 2 times 3 to the 1 times 5 to the 1. Right. And finally 108. Right. So there's always going to be a bigger number here. 108 is 2 times 54. 54 is 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. So we have 2 2's, so 2 to the 2, and we have 3 3's, right? So 3 to the 3. Okay, so that's step 1. We found the prime factorizations, right? Step 2, all right, so let's go back with the x's now, right? So 36x to the 8 is 2 to the 2 times 3 to the 2, oops, typo here, 3 to the 2. There's only 2 3's in 36, so 3 to the 2, right? So that should have been a 2, sorry about that. And then x to the 8. Right. So 48, x to the 5, is going to be 2 to the 4 times 3 to the 1 times x to the 5. 60x to the 7 is 2 to the 2 times 3 to the 1 times 5 to the 1 times x to the 7. And finally, 108x to the 3 is 2 to the 2, 3 to the 3 times x to the 3. Right? So now we have everything to find the GCF. Okay, so let's start with the 2's. These are the 2's here. And what are the exponents? We have a 2 and a 4 and then 2's, right? So out of 2 and 4, what's the smaller number? It's just 2, right? So 2 to the 2. Now let's look at the 3's, right? They all have a 3 in common here. And now we have to pick the smallest exponent. We have a 2, a 1, and a 3. So 1, 2, or 3, the smallest of those 3 numbers is just 1, 3 to the 1. Right. And now it's the same thing with the x's here. Oops, sorry, not the 5, right? 5 is not a common factor, so we don't include the 5, but they all have an x. They all have an x, they all have a factor of x. And now we have a choice between these 4 exponents, 8, 5, 7, and 3. So out of these 4 numbers, these 4 exponents, what is the smallest number? Obviously the 3, right? So it's x to the 3. 5, 7, and 8 are all bigger than 3, right? So there we go. The GCF is going to be 2 squared, which is 4, times 3, times x to the 3. And 4 times 3 is 12. So 12x to the 3. And that is our GCF. Okay, so I hope this helps, right? So if you have letters like X or Y or A or B or W, doesn't matter, right? You treat that as a factor. So you just look at all the exponents and you just pick the smallest exponent out of these numbers, right? Right. So remember, for the greatest common factor, you're looking for the smallest exponent. Don't use the biggest exponent. We'll get to that in Chapter 7. When you use the biggest exponent, you're finding what's called the least common multiple. Right. So we're not doing that here. That'll be the next chapter. Okay. So now we know how to find the GCF. Now we have to factor out the GCF. Okay, so in order to factor out the GCF from a polynomial, you're going to find the GCF of all the terms of the polynomial. Remember what terms are? Those are the things you're adding and subtracting. Right? So in our first example, this is a term, right? This is a term, this is a term, and this is a term. You're just adding up those 4 things. Well, right, you might say, but you're subtracting here, but you're adding a negative, right? So these are the 4 terms, right? So find the GCF and then divide this polynomial by the GCF, right? And the GCF will just be 1 term in this case, right? So you're dividing by a monomial, so that's going to be the easy division, at least I hope it is. And then you'll express this polynomial as the product of the GCF and the quotient. Okay, so let's see how this works, right? Let's just do step 1 here. So out of these 4 terms, what is the GCF? Right. So at this point, I hope you don't have to do your factor trees. We have a 6, a 24, a 15, and a 9. We'll worry about the negatives later. Right. So 6 is just 2 times 3. Oops. 84 is going to be 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So 2 to the 3 times 3. 15 is 3 times 5, and 9 is 3 times 3, or 3 squared. So we want to use exponents here, right? Right. So the only number they have in common is the 3. Right. So the GCF is the 3 times p to what power? So what's the smallest exponent? The smallest exponent is 2. So the GCF is 3p squared. right? 3p to the power 2. Okay, step 2. So we take this polynomial, I'm just copying it down, p to the 2, and we divide the whole thing by 3p squared. Okay, so yeah, this is not the long division that we did earlier, right? We're dividing by one term, one monomial term. So the easiest way is just to split this up and divide each term, oops, that's a 4, by 3p squared, the GCF. Right, so yeah, we did this in the last section. And yeah, this should be pretty easy. 6 divided by 3 is 2. And remember here we subtract the exponents. So p to the power 7 minus 2, or 5, right? So 2p to the 5. And then minus, right, because that's a minus sign. 24 divided by 3 is 8. And then we subtract the exponents here. 5 minus 2 is 3. Minus 15 divided by 3 is 5, and then 4 minus 2 is, 2. Oh, sorry about that. I was having some technical issues. Yeah, 4 minus 2 is 2. And then 9 divided by 3 is 3, and then 2 minus 2 is 0, so this is p to the 0. But remember, p to the 0 is just 1, right? So there you go. That's step 2. Divide the polynomial by the GCF. This is what we call the quotient. At least we did in the last section, right? But now, factoring is essentially thinking of it the other way, right? Right. So before we write down the result here, yeah, just think, right, instead of writing 12 divided by 6 is equal to 2, you can write 12 as 2 times 6, right? And so that's all we're doing. We're going to multiply the GCF by this, right? Yeah, I'll leave that here, right? So the original polynomial, 6p to the 6p to the 7 rather, minus 24p to the 5, minus 15p to the 4, plus 9p to the 2, right? So that was the original problem. We're going to write this as the GCF, which is 3p squared, times all of this, the quotient, right? So just copy that down here, 2p to the 5, minus 8p to the 3, minus 5p to the 2 plus 3. And, oops, sorry about that. Stylus issue here. There we go. So that's the answer. Okay. Now, I grant you that some of you are more comfortable with this than others. If you're more comfortable with doing this in your head, then that's fine. There's really not much you have to show here once you get used to it. But that's the idea, right? And don't forget, you can always check by doing the opposite. We can multiply this out by just distributing the 3p squared to each term. So if I multiply 3p squared times 2p to the 5, right? Well, plus 3p squared times negative 8p to the 3, plus 3p squared times negative 5p to the 2, plus 3p squared times 3. Notice what we get here, right? We get 6p to the 7, right? 3 times negative 8 is negative 24. And then p squared times p cubed is p to the 5. And then positive 3 times negative 5 is negative 15. P squared times p squared, p to the 4. And then 3 times 3 is 9 times p squared. And if you notice, this is the exact same as the original problem here. So now we know this is correct. Now, sorry I messed it up, but that was the answer. Okay, so that's how to factor out the GCF, right? See if you can do this one. Okay, so factor out the GCF from 28x to the 5 minus 32x to the 4 minus 12x cubed. Okay, so only 3 terms here. Right, so step 1, what's the GCF? So 28, 32, and 12 are all divisible by 4. Right, so 28 is 4 times 7. 32 is 4 times 8, and 12 is 4 times 3. Right, so the 3, 7, and 8 have nothing else in common. Right, so the GCF of the coefficients is 4. And then the smallest power of x is 3, so 4x cubed is the GCF, right? So step 2, you just have to divide 28x to the 5 minus 32x to the 4 minus 12x to the 3, all divided by 4x cubed. And at this point, I'm sure you can do this in your head, right? You don't have to write out each term separately. So write 28 divided by 4 is 7, and then 5 minus 3 is 2. Negative 32 divided by 4 is negative 8. X to the 4 divided by x to the 3 is x to the 1. So I won't write the 1. And negative 12 divided by 4 is negative 3. X to the 3 divided by x to the 3 is x to the 0, which is just 1. Okay, so this is the quotient. So step 3, right, we're just going to write the polynomial, in this case the trinomial, because there's 3 terms. Right, 28x to the 5 minus 32x to the 4 minus 12x cubed. We're just going to write that as the GCF, 4x cubed, times 7x squared minus 8x minus 3. And we're done. Okay? Right, try one more. Okay, factor out the GCF. 9y to the 7 plus 15y to the 5 minus 5y to the 4 plus 4y squared. Okay, so we're back to 4 terms, right? And we want to find the GCF. Let's just look at the numbers, right? 9 is 3 times 3. 15 is 3 times 5. 5 is prime, so we'll just leave it as 5. And 4 is 2 times 2. Okay, so notice that there's no 5 here, right? And there's no 2 in any of these. So there's really nothing in common to all 4 of these, right? So the GCF is 1, right? Now, don't forget the variables, y to the 7, 5, 4, and 2. So out of those exponents, 7, 5, 4, and 2, what's the smallest exponent? It's the 2. So this is 1 times y squared, or just y squared. So the GCF is y squared. Right? Okay. So now we just divide. And I hate writing this all over again, but 9y to the 7 plus 15y to the 5 minus 5y to the 4 plus 4y squared. And just divide everything by y squared. Right? So you're going to get 9y to the 5 plus 15y to the 3 minus 5y to the 2 plus 4. Right. So finally, in step 3, we write the original problem, 9y to the 7 plus 15y to the 5 minus 5y to the 4 plus 4y squared. So we just multiply the GCF, y squared, times the quotient, 9y to the 5 plus 15y cubed minus 5y squared plus 4. And that's it. I'll leave it to you to check, right? If you multiply it all out, you should get the original problem here. Okay. Yep, so even though the numbers, right, don't have anything in common other than the 1, of course, then you just, right, then you still factor out the variables, in this case the y squared, right? All right, one more. Okay, factor out the GCF. Negative 10x cubed minus 25x squared plus 15x minus 20. Okay, so here I'm hoping you see the GCF is just 5, right? 10 is 2 times 5, 25 is 5 times 5, 15 is 3 times 5, and 20 is 4 times 5, right? Now, what about the x's? X to what power? So we have a choice between a 3, a 2, a 1, and a 0, right? So 0 is the smallest, right? So this is going to be 5x to the 0, which is 5 times 1, which is just 5. So, yep, there is no x that's common to all of these, right? So, yep, so the GCF is just 5, right? Because there's no x in the last term here. Right, remember, you can only factor something out if it's common to all 4 terms. Right? You can't just say, well, the first 3 terms have an x, so I can factor out an x from the first 3. It has to be common to all the terms entirely, right? Okay. There's one other thing, though, that notice that there's a lot of negative signs here. And in particular, there's a negative sign right up front. Right? And so what I'm going to do is consider the GCF to be negative 5. Right? Because I want to factor out the negative sign as well. We want to factor out the negative. Right. And again, we typically do that when there's a negative in the leading term, right up front. Okay, so step 2 looks like this. We have negative 10, oops, make that a negative 5, negative 10x cubed minus 25x squared plus 15x minus 20, and we're going to divide everything by negative 5. Okay, so you should get 2x cubed plus 5x squared minus 3x plus 4. Okay, right. Remember, that's not the answer. In step 3, we have to write the GCF, negative 5, times the quotient. So negative 5 times 2x cubed plus 5x squared minus 3x plus 4. And that's it. If you multiply this out, you should get what we started with. Right? And indeed, that's exactly what we started with, right? So we know it works. All right. I guess I'll give you one more. Okay, factor out the GCF. We have 8r to the 4 minus 4r squared. Okay, so here there's only 2 terms, right? In some cases you'll have 2 terms, some you'll have 3, some you'll have 4. I don't think we did one with 5 terms yet, but that's getting a little bit excessive. So with 2 terms, it really should be easy here because the GCF, right, is just 4r squared, right? And when you divide by 4r squared, you just get 2r squared minus 1, right? So that was your step 2. Step 3, we just write down the factorization. This is going to be 4r squared times 2r squared minus 1. And that's it. Right? So hopefully this was an easier one. And so that's it for factoring out the GCF when the GCF is a monomial factor. Now let's go on to binomials. Okay, factor out the GCF. We have 4x squared times y minus 3 plus 5x times y minus 3 minus 7 times y minus 3. Okay, so to factor out the GCF, we first have to find what is the GCF. Right, and I'm hoping it's obvious here. What do all three of these terms have in common? They have a common y minus 3. Even though it's two terms, right, it's a y and a negative 3, that is our GCF, right? Because in particular, the 4x squared, the 5x, and the negative 7 don't have anything else in common. Right? So the GCF of those would just be 1. Okay, but the y minus 3 is the same for all of these. So the GCF is y minus 3. Right? And so when you divide by y minus 3, you just end up with the 4x squared plus 5x minus 7. Right? So to factor that out, we're just going to do y minus 3 times 4x squared plus 5x minus 7. And that's it. Right? We're done. So here I'm just kind of getting you used to the idea that the GCF doesn't have to be a single term. It could be two terms or even three terms, but we'll stick with just two here. Okay, factor out the GCF of 3x times x plus 5 minus 4 times x plus 5. Well, what is the GCF? As a big hint, right, whatever's in the parentheses here, the x plus 5 is common to both of these terms. So the GCF is really just x plus 5. Okay, so that's what we factor out. We're factoring out the x plus 5. And what does the x plus 5 multiply? Well, it multiplies 3x, right? And it multiplies this negative 4. So 3x minus 4. And that's it. Okay, so maybe I'm doing this a little too fast, but at some point, that's all this is, right? There's not much to it, right? Try one more. Okay, factor out the GCF. We have 6a squared times 2a minus 3 minus 4a times 2a minus 3. Okay, so what's the GCF? 2a minus 3? Is that obvious? Okay, so you factor out the 2a minus 3, and that leaves us with 6a squared minus 4a. Yeah, see there's a problem here, right? 6a squared and 4a have something else in common, right? So if you just look at 6a squared minus 4a, the GCF there is not 1, right? In fact, it's 2 times a. So from this, we can factor out a 2a. And when we divide, we get 3a minus 2. Okay? So the 2a minus 3 is fine, but we also need to factor out a 2a and then a 3a minus 2. Right? And when you have a single monomial term like the 2a, we should bring that in front. Right? So that should always go in front. So 2a, in fact, you don't need parentheses then if you put it in front, times 2a minus 3 times 3a minus 2. Okay, yep, so this was a little bit of a tricky one, right? If you didn't notice that the 6a squared minus 4a had something in common, then you might have left it like this. But if you leave it like this is not factored completely. Right? So you'll get partial credit for it, but you'll lose points because it's not factored completely, right? So what I mean by that is the following, right? So let's go back to just a prime factorization problem. Let's say we want to find the prime factorization of the number 50. Right? So what's 50? Well, you can say it's 2 times 25, right? But 25 is not a prime factorization, right? In other words, we're not done yet, right? We have to factor 25 as 5 times 5, or 5 squared. Okay? So this is the prime factorization, right? If you leave it like this, well, I can say 25 is not a prime number, right? And if it's not a prime, you're not done yet. So don't expect to get full credit for that answer there, right? The answer that gets you full credit is this one here, right? So this is completely correct. Same thing here, right? This is correct. This, although it is factored, it's not factored completely. So this is not entirely correct, it's partially correct. And so, like I say, you'll get partial credit for it, but you won't get full credit. Makes sense? Yeah. Now, if you noticed that the 6a squared and 4a had a common factor of 2a, that should have been included in the GCF. If you did that first, then you would end up with this much faster, right? Right. So sometimes you don't have to do everything all at once. You can break it down into steps, right? Right. The same thing with the 50, right? We didn't have to break it down into 2 times 5 squared right away. We can break it down into 2 times 25 first, as long as you recognize that you're not done with the 25. Because it's not prime, you had to factor that again, right? So the same thing here. This is not prime. We had to factor that one more time. Makes sense? All right, so maybe we'll do one more and then we'll move on. Okay, factor out the GCF. 12x squared times 5x minus 3 plus 7 times 3 minus 5x. Yeah, there's something tricky going on here as well, isn't there, right? What is the GCF? So the 12x squared and the 7 have nothing in common, right? Unlike the last problem where they did. But here, 5x minus 3 and 3 minus 5x, they're not the same thing, are they? 5x minus 3 does not equal 3 minus 5x, so, right? So that's an issue, then. It doesn't look like we can factor it out. But even though they're not equal, there's only one issue, is that the signs, right? This is a positive 5x instead of a negative 5x, right? And it's a negative 3 here instead of a positive 3. In other words, they just have opposite signs, right? And if the only issue is the signs, you can factor out a negative sign. So we can think of 5x minus 3 not as 3 minus 5x, but the opposite of 3 minus 5x, right? If you distribute the negative sign, right? If you distribute the minus, you get negative 3 plus 5x, right? Because it's a negative times a negative is positive. But negative 3 times 5x, of course, is the same thing as 5x minus 3. Just change the order, right? So there you go. So the thing you're looking for here, right, is when you have the terms have opposite signs, right? In other words, if you have a minus b and b minus a, no, they're not the same thing, but you're just subtracting in the opposite order. So what you end up with is negative 1 times b minus a, right? I mean, try it, right? If you have, 12 minus 7, that's not the same as 7 minus 12, right? 12 minus 7 is 5. but 7 minus 12 is negative 5. So you can think of 12 minus 7 as the opposite of 7 minus 12. Right? Oops, because 12 minus 7 is indeed 5. And then 7 minus 12 is negative 5. But the opposite of a negative 5 is a positive 5, right? So yeah, when you're subtracting in the opposite order, you can always just pull out a negative. And so that's what we're going to do here, right? We are going to write this as 12x squared times 5x minus 3 plus 7 times negative 1 times 5x minus 3, right? We need that negative sign, right? Okay, so what that does is this makes this a 7 times negative 1. We can write that as negative 7. So everything else is the same, 12x squared times 5x minus 3, but now it's negative 7 times 5x minus 3. And by doing that, now we can see that we have the exact same thing in both terms, 5x minus 3 and 5x minus 3. So that is our GCF, and that's what we can factor out, the 5x minus 3. Okay, so what does that multiply? Well, it multiplies 12x squared minus 7. Right, and now there's nothing else to do here. The 12x squared and the negative 7 have nothing else in common, so we know we are factored completely. Okay, so yeah, again, a bit of a tricky one when you see the terms in the opposite order, right? And they have opposite signs. Right? In other words, this is a positive 5x here. This is a negative 5x. Right? This is a negative 3 in the first one, and this is a positive 3 in the second. Then you know you can always do this trick of factoring out the negative 1. All right, so I hope that helps. I think I'll give you one more, and then we'll move on to the next section. Okay, factor out the GCF, 6x cubed times x minus 4 minus 4x times 4 minus x. I think if you can handle this, you should be good here. Okay, so what's the GCF? Well, it's not x minus 4 because 4 minus x is not the same thing, but it is the opposite, right? So the first thing I would do is change the 4 minus x to negative 1 times x minus 4. And by doing that, we have a negative 1 times a negative 4x. That's going to be a positive 4x times x minus 4. Okay, so now we can see the GCF is x minus 4. On the other hand, the 6x cubed and the 4x also have something in common. They have a 2 and an x. So we're actually going to factor out the 2x times x minus 4. Okay. On the other hand, if you'd rather go step by step, maybe we should do that. Let's factor out the x minus 4 first, leaving us with 6x cubed plus 4x. Okay. But we can't leave it like this, because 6x cubed plus 4x is not prime. Right? It's not a prime number. We can reduce it or factor it further. Okay, so the x minus 4 is prime. We're done with that factor. But 6 and 4 have a common factor of 2. And x cubed and x have a common factor of x. So the GCF is the 2x that I mentioned earlier. So when you factor out the 2x, right, you're going to end up with 3x squared plus 2. Right? 6x cubed divided by 2x is 3x squared, and 4x divided by 2x is just 2. So I think we're good there. And now, just don't forget to pull the 2x in front. So we have 2x times x minus 4 times 3x squared plus 2. And that's as far as we can go. Okay, everyone got that? Incidentally, in terms of the two binomials, it doesn't matter what the order those are in. So as long as you have the 2x in front, you can also put the 3x squared plus 2 in front of the x minus 4. Right? So the order there doesn't matter. And yes, you could leave it with the 2x in the middle here, but then you need parentheses around the 2x. Right? It's just customary to pull the monomial factor, the single term, the monomial, right, or one term in front. When you have a binomial, binomial, two terms, say the x minus 4 or the 3x squared plus 2, those can go in any order. Right? So I would accept either of these on the right here. So both of these are correct. And as far as this goes, it's just a little sloppy. So, maybe I take a point off. I certainly take a point off if you don't include the parentheses around the 2x. Those are crucial there. Right. And of course, you can always put parentheses around the 2x here. But in this case, they're not completely necessary. All right. Yeah, this is about as hard as it's going to get here. And then we have one more thing to do in this section. And that's going to be factoring by grouping. So now we have to factor by grouping. And you know what? I think we'll do this in a separate video. This is getting long enough already. Okay, so this is part 1 of this section.